Hey guys, welcome back to this channel, and I'm very sorry for not uploading the videos regularly because I was unable to do that and because I was on vacation. So now we're going to discuss yesterday's problems and what are the available approaches to solve this problem. Okay, first of all, we're going with the explanation of the question. See, this is very simple question. They have given a grid of matrix where each value in it's representing the height of a particular thing. You can think it as the height of a building, and and he also says that the water level increases as the time increases proportional to it. For suppose the time is 3, then the water level is also reached to 3. Okay, here they are saying that we can swim in that water in 4 directions, and we can able to go to the next square if and only if the elevation, or we can say the height of the corresponding adjacent square is at most t. What does it mean? For suppose you are in you are at a building of height 3, and like the water the adjacent things having height 2 and 4 and 4 and 5 and 6. So now the water level is 3. It means you can swim and able to go to the places that are having height less than 3, because the height objects having height less than 3 are submerged in the water, or any height equal to that water level we can swim in there, right? We can swim and go to that particular place. So they're asking the minimum time. uh, they are asking, okay, as the time increases, the water level also increases. So what is the minimum time you must wait to reach the final square if you start from the zero? Here you can see the example one. You started at this particular thing, and for suppose you cannot go else anywhere where other than t, because t is zero means water level is zero. You can't go to either this one, or this one. But when you waited for 1 second, the water level is came to 0 to 1. Then you can swim and go to this building, right? Then whenever you waited another second, you can actually go to, okay, you came from 0 to the 1, and if you waited 2 more seconds, the water level is increased to the 3, and you can swim to the building 3. Okay, so the minimum time here required is 3. In the same way, you can see the example 2. So we are going in a best way. So, uh, right. Okay. First of all, I'm going to discuss. We can solve this particular problem in two approaches. One is you can use your well-known algorithm, Dijkstra's algorithm, and second thing is you can also use depth first search aligned with the binary search. Okay. Mm, yeah. So simple. You don't have to think this as a very tough and hard and complex code. If you are well understanding about Dijkstra's algorithm, you can able to easily think it in the similar way. See, using the Dijkstra algorithm, we are going to find the best minimum path to reach the destination from source. What there we are going to do is we are going to choose only the best simple low cost way to the next position, right? In the same way, first things first is here the directions are very important. Okay, four directions we have created in 2D array. Then next, these all stuff are very required, right? See, this particular priority queue. Actually, we have to use a queue in Dijkstra's algorithm, but here we are using a custom comparator inside a priority queue, which when you want to add your custom defined object into it, it uses this comparator. Now, if you write like this, like since it's an integer array, we are trying to access the first item which is at index. That means we are trying, wait a minute. Yeah, as you can see, we are going to use Dijkstra's algorithm. We can only move to the adjacent cell, which requires very less water level. That is what we want, and the time will be updated. See, when you went to the new cell, okay, you make a movement to the new cell. We will update the new time, current time as is, which is the maximum time between now current time and adjacent cell. So when we reach the final destination, we will return the time. So the algorithm says we are going to use DFS, we need to use queue until the queue, until the queue, the elements in the queue are empty, we are going to repeat the process same, and we store this custom object time I comma j into the priority queue with time in ascending order. Okay, the first thing here is we are going to, yes, first we'll add one item, that is grid 0 comma 0, starting position source is 0 comma 0, and until this queue becomes empty, you are doing this whole process repeats until there are elements or entries in the priority queue. Here first we're going to pop the element from the priority queue. Remember, it gives the entry or an object that is having very less amount of time. We're taking that out and we're checking some conditions. If it is visited, we don't have any work with that. We'll just continue, or else we'll make it true, and then we check if it is whether we are at the final end position. No, right? If it is not happens, we have to go through these four directions for I comma j, and while when we went, we have to check this also, right? The when and checking this, and we need to add into the priority queue, because when we went to the next position from the current I comma j, we have to start again this process from that place. We have to update the time, location. Then this will be the next entry. We will update the time with current time comma or its grid time. Now the again process will be happening. See, every time among the group, see, uh, why we are using this priority queue means, if you if we want to find out the best minimum time possible for the particular thing, okay, less time, which is having very less time, for that purpose we are using to easily access in order of one, easily access the position that is having less amount of time, that we are going to check with help of priority queue. At final we are returning -1, or else we are returning the, okay, at last we are returning the final answer -1 if there is no way, and here only we are passing the time if it is found. Okay, yeah, absolutely, this is going to be work very well. Now now we are going to discuss the approach to, see, the approach to is like we're going to use the binary search. See, this is very simple and easy for you to understand, since we are going to use here is binary search. plus DFS. So, binary search plus DFS. See, this is very familiar for you and us. Okay, the starting time. See, if you check the constraints, wait a minute. If you check the constraints, you can able to find out that the grid value is at most n square and n value is 50. So 50 square, 2500. So the time must be between 0 to 2500. So we are starting from right side, means the upper bound of the time n square minus 1, and lower bound will be the grid of 0 comma 0. This will be the 0 comma 0. Okay, we are following this particular rule to apply the binary search. We will find the mid value, and for this time, if we can reach the end or not, if we can reach or not, we're going to check it. This is the boolean that we need to use while traversing. Okay, see here the if condition. If we are able to reach the end using this mid time, then we are trying to decrease the right side, move it to the left side, same as the binary search. Now, if you can check the can reach function, you can see the arguments, the grid visited, the position, and we can also find the t, that is estimated time. Yeah, here is some base conditions. We are checking the boundary conditions, if it is visited or not, and if the grid of time means like the surrounding areas are having greater time, greater height than this time. Indirectly, we can say that the current grid height is adjacent grid size is greater than the current water level. We are absolutely returning false because the water is very low when compared to height of the building. Now, this condition, if this particular condition is true, you are absolutely going to return true. Okay. If above two conditions are not performed well, then this is the new first time we are entering into this position will make it true. And for the four directions from here onwards, you will again call the can reach function. If any one is true, you will return the true. If these are all conditions, let us say these all conditions are failed, then we are going to return false. So I think this actually helped you a lot, and you understand. I think so. Okay, let's show you what happens when I run. Yeah, yeah. This works very fine. Absolutely. Okay. Uh, okay. Thank you for this. Thank you for watching the video. And in the future, I will try to upload the videos as soon as possible. And like, share, and subscribe for more simpler explanations of the lead code daily problems. In upcoming sessions, we're going to start not only the lead code problems but also some concepts data on AI, data science, and machine learning. Okay, thank you. Have a good day.